Hey, hello. I was expecting a little bit less people because it's after lunch and you guys probably fall asleep, somewhere. But yeah, I see some people have coffee, so don't fall asleep while I was talking, right? So thank you. So thank you. My name is Alan, Alan Chang. I'm part of the Inspur product team, and I'm gonna do a little bit of software talk today. So hopefully you'll enjoy it. So kick off the conversation, we want to talk about a little bit about Inspur, right? Inspur is one of the top 3 server vendors out there in the world. So as you can imagine, we're serving a lot of big customers, hyperscale customers. And then with our shipping value, it's obviously one out of the top. And not only just on the server side, we're also really focusing on AI computing as well. So we do have a very full stack of software capability for the AI application from the hardware perspective and then from the framework fine-tuning, and then all this stuff, right, and into the complete solution. So we're also leading open data center product producer solution provider. Obviously, we're talking about OCP today, but on the other side of the ocean, there's the ODCC community. And I'll talk about a little bit about our strategy, how to merge ODCC and OCP, which is really 2 of the biggest community out there in the world today for open hardware. And I'll talk about that a little bit later too. So in our vision, right, how does the open community has to work out, right? Well, in OCP, it's really focused on the hardware. We see a lot of ODM partners out there in the world. And then there's OCP, which is a major hardware value is going out there. And like I talked about earlier, like ODCC, that's happening in China, it also has a very tremendous amount of values that's going out there. So one of the concepts that we want to bring into the market, and one of our Inspur's differentiator, is why can we, using some mature product or building blocks that we have in ODCC, and then give it a little bit different form factor, right? We don't have to reinvent the wheel because someone just wanted brand new. If we give it a different enclosure, we can actually provide an open rack ORV2 system based on ODCC building blocks, or we give it like a Project Olympus enclosure. We can actually give it a Project Olympus a new flavor or new alternative to what you see today on those major hyperscaler who's consuming today. So that's one of our vision, right? And of course, we all have some sort of open power stuff as well. But the really focus today is really on the software perspective, right? If you purchase, as you can go through the Open Compute Project wiki site, you see a lot of contribution on the Gerber file, like schematics and all this hardware, AutoCADs, right? All these files. But one thing you have been missing is really the source code of all this firmware, which is really important to your operation, like the BIOS, the BMCs, right? Like those are not available because there's a proprietary code that's embedded into it. And then that's why we're driven and want to provide like Open BMC, Open RMC to the community, and to kind of bring in a little awareness to it. Like we don't really, this is not really like a commercial conversation keynote speech, right? I'm not really trying to sell me the product, but I want to bring awareness on how Inspur as a company, of course, we want to sell you product, but of course, on the other side, how do we as a community really join together to have like Open BMC, Open RMC, all this open source stuff like happening in the community, and then make it really truly open a platform, not just the hardware itself, right? Also the source code itself. So let me talk about Open BMC, right? Last year, we contributed one of the Open BMC stuff on the GitHub, and then also we contributed some sort of Redfish code as one of the OCP hand notes. So I think this is a continuation of what we're trying to do as a partner to or as a member of OCP. So if you look at this chart, we joined OCP in 2016. We're not the first one to join the OCP, obviously. But once we joined, we really put our full investment into it, right? We have all this different open rack stuff, and then the Project Olympus hardware product, and then with LinkedIn joining OCP as well, we also have product developed for Open19. So we're really embracing all this open hardware community to make sure everyone has different choices, everyone has different alternatives, and everyone has like different workloads. They can find something they want in our portfolio. And then last year, just like I said, last year, we're the first one to have an OCP-based compute node with Redfish, and that's our contribution. And this year, I'm gonna talk about Open RMC. the rack management controller software. And these are some of the key features that we want to just open the communication, initiate the communication with the community. Is we actually going to contribute all this, everything to GitHub with the source code. And then hopefully someone with enough interest can talk to us and then start working with us to actually make it a little bit better every year and year on. So we already have the web UI for all the information that we collected through BMC, the Open BMC base, and it's also Redfish. And then the firmware lifecycle management, I think, is one of the very important key part of this whole thing that we want to talk about, because you're gonna update BIOS and BMC throughout the lifecycle of your server product, right? With all these security threats coming out here and there. And then you want to have a management tool that you can actually batch release and replace your firmware at the same time, and then it's under one roof of manageability. And that's the reason why we have this conversation, because I do believe most of the hyperscale data center, they have their management tools. But what about you? Do you have a management tool that you can actually reliable use to actually do all this work like the hyperscale guys? Probably not. The chances is probably not. But we want to use the community as a force to actually create something similar to the hyperscale guys were doing, and then without you investing too much of your effort on your own. All right? So let's try to take an example, right? This is a very standard OpenRack ORV2, and you're probably seeing it like everywhere, right? And then we're not the first one to talk about RMC, and as you can imagine, there's a lot of hardware provider, right? Like hardware vendors already building the RMC into their power solutions, right? Like the centralized, the power shelf. But one of the things is like when you try to add feature to it or reduce feature out of it, you don't have access to it, right? All this source code, again, it's proprietary. A lot of vendors gonna tell you, I cannot release the source code to you unless you get the license from someone else, right? And then all this is create a different hurdle you have to jump through. If we can, as a community, using the existing infrastructure, right? I'm not creating anything new. I'm just bringing awareness, like we can use the same board as you purchase from any of the power supply vendors today. Using that same board, any ARM chips will do, right? It doesn't have to be any specific vendor of the ARM chip they have, but any ARM chip that they do, you can use this. Well, this is a reference that we have, right? It's using ASP as one of the ARM chip. But as a reference, you can tweak the code yourself. Just really depends on what you need. Again, I think we want to have community as a joint force to create this all together. So the way we're seeing this is you can absolutely have everything connected to the network, right? But what about we have extra alternative as an I2C? There's some communication you can just rely on networking, right? If you talk about fan controller, right? If you talk about power supply, they don't have network building into it, and you don't want to waste like extra networking management port just because you want to communicate it to the power supply or communicate to any individual fans. And you want to have all this, one of the things we kind of envision is like, if you have a rack management controller, you could really optimize your data center workloads and your environment, right? We can add extra thermal sensor to the rack. It's never been done before, but as you have more gears in your data center, the utilization and all this air conditioning, right? Like all this stuff is getting a lot of waste. And if we can have the hardware to do more than just today, and then we have a way to manage them, I think there's a lot of saving that could happen in the future. But as again, like we just need to think about that as today, and then or it's just gonna be there's no start, and then no one's gonna contribute to that, and that conversation just ends nowhere, right? So our proposal is, yeah, you can have a lot of communication through BMC. You get tons of information already, but there's certain parts of the rack that you don't have. We should community as a whole. Maybe we should say, oh, what about OpenRack 3.0? What about OpenRack 4.0? What about Project Olympus 2.0? As a community, should we add some extra signals, layers to that rack to have more control of the entire rack, right? So this is just a basic idea what we want to try to say, right? Does it make sense so far? Or, yeah? All right. So I was told right? Even though this is not meant for commercial, I want to talk about a little bit more about commercial app in the last couple of slides. Our goal as Inspur, we want to be more open, agile, and converge and to everyone out there in the world. And then I think the goal is like to give you the best product, reduce your TCO, and then make sure you have the power consumption that you can actually manage it and reduce the power of all these servers. Like the CPU is getting hotter and hotter. You have more GPU cards in there, and all this, right? So building from the ground up, right? We want to understand your use case. We have a lot of design bases that we can actually leverage the common building blocks, either from the ODCC or the OCP, and then create something specific to your needs. And then we want to contribute all this IP to the public to make sure we all understand like how can we improve things here and there. And then, of course, the end of the day is like we want to join design this product with you, right? We don't want to just tell you, hey, this is what you should buy, and without your perspective, right? Jointly working together and design something for your specific need. It's ultimate goal for us as Inspur. So let me come back to what we try to accomplish, right? We talk about the ODCC, the OCP. We all know Facebook has some great gears out there, right? But it's more specific to their workloads, right? But if we could create some sort of alternative, a mature alternative, not just some random product that I create from my backyard without being proven or tested or validated through thousands of testing cases, right? We taking a lot of ODCC product, which is the Open Community Project in China, and there's a lot of values out there. If we can use those building blocks, right, create a different form factor to the power delivery, then we could definitely have some more alternative to what's being offering today in the Open Rack, in the Project Olympus. And then that's the goal. And then it's faster to actually bring those products to speed, right? We have a major motherboard that we use in ODCC the other day, and then we have a customer say, oh, I love this, but I want to have this into an open rack chassis. The only thing we have to do is actually create a new enclosure, a chassis enclosure for it. And then the power delivery is almost just so similar, like you don't have to create anything new, right? You have a bus bar over there too. And then I think that's just the original goal for what we try to convert. So with that being said, we already did have a lot of products that's available as alternative. So our booth is in the back right there, and then you definitely want to see those in the Open Rack ORV2 form factor. And those are the J-bars and the compute and the storage that we have. And then I think you will see a lot of different benefit, right? If you first time seeing this alternative, please try to ask one of our hardware guys, and then try to understand why we create this, and then what kind of workload can you actually try to satisfy. So if you were in the keynote today, we are also contributing a lot of different 19-inch form factor product to the market space, right, to OCP. Because Open Rack is great, but when you talk to your operation guys, you might say, oh, I can buy a new rack. I have like existing 19-inch rack already. I love your idea, but I just cannot do it, right? So our idea is taking all these building blocks, right? It really doesn't matter what kind of form factor it has to be, right? The OCP idea is just open hardware. Everyone could have different ideas and different concepts. It doesn't have to be detected by Open Rack or Project Olympus. So our idea is, hey, if we can throw you something and contribute everything like the Gerber file and everything for you guys to review, and it's a 19-inch form factor, you guys should be able to actually test this and then understand the benefit of it before you actually jump through the entire hoop to actually create a different infrastructure, right? So this is a 4-socket platform that we jointly announced with Intel, and then it has a lot of optimization for cloud. And then please talk to our guys in the booth, and you can understand a little bit more detail. And Intel guys are having a separate session right after this, and then you should definitely join that too. And then also, one of the interesting part, as I mentioned earlier, like we are really into AI. What I see today in the market space is I don't see any 4-socket platform is connected to any of the GPU. And we have a customer who was specifically asking for this, and then what it turns out is really amazing is we actually see a significant increase in terms of the performance, right? Like 20 to 60% in terms of the workload performance increase when you replace the 4-socket with the replace the dual socket platform with a 4-socket platform. So that's definitely for some HPC or GPU enthusiastic people out there in the world. So if you're interested in that, please definitely come to our booth again, okay? So my time is up. I'll stick around a little bit. If you have any question, feel free to talk to me, and then I'll be here throughout the days. All right, thank you.